Hello students, welcome back to Physics with SAFDAR. Now you are watching Fbise Past Paper Solution series. Today we are going to solve grade 9 2018 numericals. So let's start the solution. This is question number 6 from section B. The question is, a stone attached to a 1 meter long string is moving with a speed of 5 meters per second in a circle. Find the centripetal acceleration of the stone. First look at this diagram. This is the string we have of length 1 meter and one stone is attached at its one side like this, and it is moving. In this rotation the speed is given 5 meters per second and you need to calculate the centripetal acceleration. In numerical, first write information given and required. We have length of string that is equal to the radius of circle, so you can write length of string is equals to radius and it is 1 meter in length. You have a speed 5 meters per second and we need to calculate the centripetal acceleration. Now you need to write the formula of centripetal acceleration. Centripetal acceleration you can calculate by using this formula. AC is equals to V square over R. Now you can substitute the numbers. V is 5 over R, that is 1. 5 square gives 25. At the denominator we have 1. So finally we get 25 with unit meter per second squared. Now this question number 14 from section B. A machine is 12% efficient. If useful work done by the machine is 6 joules, then calculate the total energy consumed by the machine. The topic of the question is efficiency, and you know well what is the meaning of efficiency. It is the ratio between required form of output divided by total input energy. First write the information given and required. We have value of efficiency 12%, so you can write efficiency is given 12%. Then work done by the machine is 6 joule. Work done by the machine, that is the useful energy converted by that machine. So you can write this is output work done or useful output energy. It is 6 joules. And what is the task? You need to calculate the total energy consumed by the machine. The total energy consumed by the machine means the total input energy. Calculate total input energy. This is the formula of efficiency. Now you can substitute the values. The efficiency is given 12 is equals to, at the top, useful output energy, that is 6 joules, divided by total input energy. I am going to write with the symbol E. We need to calculate this energy in times 100. Now make input energy as the subject. So you can do that. Energy input is equals to 6/12 times 100. After the simplification, we get 50 joules, and that is the final answer. This question is taken from section C, question number 3, part B. The question is, find the magnitude and direction of a force if its x component is 12 Newton and y component is 5 Newton. Look at this diagram. Let's suppose this is the force vector and you need to calculate. The direction means angle with the x-axis, so you need to calculate this angle. Now, what are the information given and required? Look at the question. Its x component is 12 Newton. So x component means this is fx is given, so you can write here x component fx, and it is 12 Newton. Then you have y component, Fy is equals to 5 Newton, and you need to calculate resultant force F. In second part, you need to calculate its direction. Direction means angle with x-axis. The components you can see in the diagram. This is horizontal component and this is vertical component. Now, you can see here horizontal and vertical components are perpendicular to each other like this. Horizontal and vertical. You can see here horizontal and vertical component, they are perpendicular to each other. So resultant of these components you can calculate by using the Pythagoras theorem. So you can write here f squared is equals to fx square plus fy square. Now you can substitute the values. Fx is equals to 12 Newton. Fy is 5 Newton. Now simplify the expression. 12 square gives 144. 5 square gives 25. Then further you can write like this. 169, and we need only f, so take a square root on both sides, so you will get 169 with the square root, and finally the root of 169 is equals to 13. So that is the magnitude of the resultant force. Now you need to calculate the direction. The direction of resultant vector you can calculate as direction is equals to theta with x-axis tan inverse vertical component divided by horizontal component. Now you can substitute the values. Tan inverse vertical component is 5, horizontal component is 12. After the simplification we get 22.6. So that is the direction of force vector with x-axis. This is question number 4, part B from section C. The question is, the acceleration due to gravity on the surface of moon is 1.62 meter per second squared and the radius of the moon is 1740 kilometer. Find the mass of the moon. First write the information given and required. We have acceleration due to gravity on the surface of moon 1.62. You can write gravity at moon is 1.62 meter per second squared. Radius of the moon is given. Radius of moon 1740 kilometer. Find the mass of the moon. Mass of moon. When we deal with planetary system, then you need to write the gravitational constant, that is capital G. You can write capital G 6.67 into 10 raised to the power minus 11 with unit Newton meter square per kilogram squared. Look at this diagram. This is radius of the moon and gravitational field strength on the surface of moon is Gm, and what we need to calculate its mass. Now you need to write the equation which is used to calculate the mass of the moon. So you can write the equation as mass of moon is equals to radius of the moon squared times gravitational field strength or gravitational acceleration due to gravity on the surface of moon Gm divided by capital G, that is your gravitational constant. Before substituting the values, the first thing you need to check the units. The acceleration due to gravity in SI unit. Radius of the moon is not in SI unit. It means you need to change. Now you can convert kilometer to meter as 1740 kilometer multiply 1000. We get 174 and 000. Now the radius is in the unit of meter. It is better to write the unit in the power of 10, so you can write 1.74 into 10 raised to the power 6 meter. Now you can write 1740 kilometer into meter is 1.74 into 10 raised to the power 6 meter. Now you can put all the number in the equation. The radius of moon 1.74 into 10 raised to the power 6 squared times G at moon, that is 1.62 divided by gravitational constant, that is 6.67 into 10 raised to the power minus 11. After the simplification, we get 7.4 into 10 raised to the power 22 kilogram, and that is the final answer. Thank you very much for watching the video. Follow the playlist of the channel. In that you can find all the things you need in your Fbise physics. So keep watching Physics with SAFDAR for better results in exam. See you in the next lesson.